Hello, Algebra 1. Let's go over the homework from the yellow book, which is on page 43. So we have this xy axis, and this is problem number 10. So we want to plot the point and label it C30. And then I also want to plot 0, 5. You might need to draw in the xy axis on your um, grid that's given. So I have negative 3, 0, which is here, and 0, 5, and label that C, and 0, 5 here. So what we're going to do is we're going to count, starting from the left, we're going to count up 1, 2, 3, 4, 5. So 1 up 5, so that's positive, and right 3. And because we went right, it's positive. So our slope is going to be 5 over 3. Remember, it's the vertical over the horizontal. Number 11, I draw in my y-axis. I have point E being -2, -1, and point N being -4 and 4. So -2, -1 is point E, and then -4, +4, it's up here. So then we're going to go ahead and that's point N. So we're going to count down 1, 2, 3, 4, 5, and right 2. So it went down 5 and right 2. So our vertical direction is -5 over 2. So remember, it's V over H. Number 12, we have our xy axis here. Our point S is 0, 3. Our point W is 1, 6. So let's go ahead and graph 0, 3, point S, and then 1, 6. That'll be W. So if we wanted to count up, I'm going to go 1, 2, 3 up, so +3 up, and right 1 over. That's also positive, so our slope is going to be the vertical over the horizontal, which is 3 over 1. It's positive. Go ahead and turn the page. And they have a linear equation given. So let's see if I can draw it. And so I'm going to go ahead and draw this. Try and draw a straight line. I didn't do so good. All right, so let's figure out the slope first. I'm going to go up 1, 2, 3. So I went up 3, right 1. So our slope is going to be 3 over 1. Okay, so there's a couple other things on this problem, and I just wanted to kind of teach it. You didn't have to do it. You just had to find the slope. So B is called the y-intercept. So this is the y-axis here. So what is that point? That is the point 0, 2. So that y value there is our B value. So then we're going to go and we're going to use this equation, which is called slope-intercept form, which is y equals mx plus b. You'll use this an awful lot in math. And we're going to plug in our m value for m and our b value. You'll leave the y and the x alone. So 3 over 1 x, and it's a +2 plus 2. This is our actual equation of the line. So make sure you add that to it and ask me if you have any questions. Number 14, we have this linear equation here. So it looks like I got a point there. And I have a point here. So on number 14, we had those 2 points. It looks, and the reason I have these 2 points drawn on here is I needed to figure out 2 places I could definitely see where it's happening. So if it looks like if I go down 4, so I went down 4, that's negative, and right 1, that's positive. That means my slope has to be -4 over 1. And then, again, remember what I said on the last problem. Now we're going to look at this, where it crosses the y-axis. That's our b value. Okay, so this looks like to be 0, -1. So our b value is -1. Now I can go back to the equation y equals mx plus b, and I can plug directly in. And I can put that over 1 if I want. It's not necessary, but notice I have a negative number there. Let's go to number 15. And again, I have to kind of figure out what 2 points work on there. It looks like I have 5, 0. There's a point there. And again, I'm looking exactly where it crosses. And then it looks like at 0, -3 down here. So our line would have done this. Okay, so that's 5. All right, let's find our slope. So I'm going to count up 1, 2, 3. So 1 up, so that's positive. And I want 1, 2, 3, 4, 5. And that's positive 5. So my slope is the vertical over the horizontal. It's positive because they're both positive numbers. Let's figure out our b value. Well, this is our y-intercept. So that's my b value. So 0, -3. This is my b value right here. So I get this. Then I'm going to use the template y equals mx plus b. I'm going to plug in my slope, which is 3 over 5, x minus 3. Number 16. Number 16 looks like I have up here at 4, and I'm looking where the line crosses exactly at the intersection. And let's see, it looks like 4, 2. That looks like another point. So here's our line. So let's figure out our slopes. I'm going to go down 1, 2, and then right 1, 2, 3, 4. So I went down 2, right 4. So my slope is going to be -2 over 4. You can leave it as 2 over 4, or you can try and reduce it, which it would be 1/2. It doesn't matter really when you're dealing with slope if you reduce or not. That's going to be my y-intercept. So that's going to be at 0, -2. So my b value is the y value of that. And we use the template, b equals -2. And then y equals mx plus b. Let's plug -1/2 in, and then -2. Okay, so that's basically the homework. Few key ideas. Would you turn in your yellow book to page 45? Page 45, it says, Jumpstart, it says, the super discount store is having a sale on all clearance items that are 40% off. Which of the following are correct ways to find the price of an item that is $25? Okay, so think about this. There's 4 choices. They said, can we multiply 25 by 40? Can they multiply 25 times 0.4? Can they multiply 25 by 4, and then whatever that answer is, subtract it from 25? Okay, something like that. Or can we multiply 25 by 0.6? Okay, so let's talk about a few things. It says the super discount store is having a sale. All clearance items are 40% off. Which of the following? So let's think about this. I have a $25 item that I have a sale price, and it's going to be 40% off. Okay, so if it's 40% off, what value would this item be? Is it going to be less than 25? You agree with that? If I find 40% off, that tells me how much I would take off the price. So what I have to do is I have to realize that I'm going to pay 60% of the original price. Okay, the reason it's 60%, if I go 40% plus 60%, that becomes 100%, which means I'm going to take 25 and I'm going to multiply it by the 60%. Well, remember, 60% is the same thing as 0.60. So if you multiply those together, that's going to be, and I'm going to do the multiplication right here because I don't have a calculator with me. That's 15, and decimal right there. So my item is now going to cost $15. So hey, that's kind of a good deal. If you something costs 25 normally and you're going to pay 15, so that's your price. Okay, so as we go down the page, let's take a look. It says they're talking about some prairie dogs, those little ground squirrels that are around. They're on 120 acres of land. As the surrounding land is more valuable to humans, the size of the reserve has been reduced. So at year 1, 2, 3, 4, and 5, the very start of it, there was 120 acres, and then it dropped down to 112.5, then it dropped down to 105, and then it dropped down to 97.5, and then it dropped down to 90. Okay, so do I have a common difference or do I have a common ratio? Am I subtracting the same amount each time, or am I multiplying by a factor? Well, let's take a look at this. This looks to be about 7.5 less. This looks like it's about 7.5 less, as does this. So they're all dropping by the same thing, so I have a common difference. We'll call it CD for common difference. Okay, so our recursive will be last minus 7.5, and my explicit function is going to be, and so this is going to be arithmetic because I was just subtracting, right? All right, so we're going to use this value. So I'm going to go f at n equals negative 7.5 n, and then my starting value is this. Let's see if we can make this work. Plus 120. Okay, so think about this. If I were to take this 1 and plug it in right here, do I get that 120? The answer is no. Remember, it's pointing down 1. So we have to change this a little bit. So remember with the exponents, I was changing this to an n minus 1. So I wonder what would happen if I did this. What would happen if we did that, do you think? Is that equation going to work? Let's take a look. Let's use a fancy color. So if I take this 1 now, and I plug it in here, I'm going to get 1 minus 1, which is 0. 0 times negative 7.5 is 0. 0 added to 120, does that give me 120? And that is our answer. So we can keep it like that for now, but you also might remember back in a different class, I could maybe distribute this over. So watch what's going to happen here. 7.5n plus 7.5 plus 120. These are like terms because I don't have a letter attached to it. What about this equation here? And what math did I do to get there? These equations are the same. This one is just more of a clean version. This one's right. I would take that answer on a test or a quiz, but this one's more cleaned up because we got rid of our parentheses. Okay, this allows us, basically what that equation allows us is it allows us to say, hey, when we started out things, we noticed there's these prairie dogs on 127.5 acres, and then we started enclosing it. Go ahead and turn away, or turn to page 46 in the yellow. It says the sale of the land of the reserve stopped when the reserve was 76.5 acres because biologists who studied the prairie dogs found that the population was declining at an alarming rate of 20% per year. They determined that the decline was due to several factors, including the reduction of a habitat from selling off reserve land. When reserve began, the prairie dog population on the reserve was about 600 individuals. Okay, so this is now number 5 on the top. So they said they stopped building when they were down to 76.5 acres. They said the population was decreasing by 20% each year. Okay? When they started the thing, there was 600 prairie dogs. Okay. So model the prairie dog population over time in years with the beginning population. Okay. So we are losing this. That's a downward. So I'm going to make it minus 20%, which is the same thing as 0.20. Okay, I notice I lost the decimals here, so you move it 2 places to the left to get rid of the percent sign. So what percent of the population, if I lose 20%, that means I would have 80% of my prairie dogs there, which is 0.80. Okay? So let's think about how this equation would work. So we have the explicit, which is going to be last times 0.80, because that's going to tell us how many prairie dogs. That's why we want to use this value and not this value. Okay, the 20% means how many fewer we would have. The 80%, because 80 plus 20 would mean we have something taking place. Okay, so because I am multiplying, this has to be geometric. So then our recursive function is going to be this. We're going to go f at n equals, we started with 600 prairie dogs. We are now going to reduce that to 8.80 raised to the n. Okay, and if n were to start at year 0, that would mean year 0, when we first came out to the prairie dog land, there were 600 prairie dogs that they had counted. So this is our equation. Okay. So number 7 says, how is decreasing arithmetic different than decreasing geometric? If you decrease arithmetic, you're subtracting. If you are decreasing geometric, you are multiplying by a value that is less than 1. So a fraction that's less than 1. Okay. So I think we can move on. And what I would like you to work on, or let's take a look at page 48. So problem number 1, we have 3, 9, 27, blank, 243, blank. So what does it appear that each of these numbers is doing? How do I get to each number? Am I adding? Am I subtracting? Multiplying? Well, I think I'm multiplying by 3. So if I multiply this by 3, 27 times 3 is 81. Multiply 81 times 3, get 243. Multiply 243 by 3. Okay, because we're multiplying each time, this means it would have had to have been geometric, right? Okay, so we don't have a common difference. We have a ratio. Our ratio is times 3. There's not a so we have a ratio. So the answers to A and B are that. So the answer to A is its ratio. The answer to B is times 3. And then this would have been geometric, which we labeled above. That's all we had to do. Okay. If you look at problem number 2, on page 48, you have 3, 9, blank, blank, 27. And then they have the dots like it keeps going, which we kind of know. All right, so let's see here. What do you think is taking place here? If I go 3 times 3, that gives me 9. If I go times 3 here, I get 27. Well, 27 is over here, so it's not times 3. Maybe see if we, what do you think? If we add 6, if I add 6 here, if I add 6 to 9, that gives me 15. If I add 6 to 15, that gets me to 21. If I add 6 to that, that gets me to 27. So we have a common difference. Okay. So that's the answer to A. B, our common difference is we are adding 6. And because we're adding, it's arithmetic. That's all we had to list. We're just trying to figure out the rest of it. And then problem number 3 down below, I'm going to graph this. So I had to draw my own grid. So I have -2, 0. That's point M. And then I have 4, 2, which is R. And so we want to find the slope. So it looks like I go up 2. So that's +2. And I went right 1, 2, 3, 4, 5, 6. So my slope has to be 6 over 2. You could also make it 3 over 1 if you wanted to. You could also make it 3. It's not that big of a deal, one way or the other. So then we have to think about this. Where is it crossing the y-intercept? I mean, if I drew my line and my line's not going to be that good, where did it cross? What's my b value? And the answer is we don't really know at this point. There is a way to find it mathematically, but we don't have enough knowledge of how to do it yet. I mean, the way you actually do it is you use an equation called point slope. And this is different than y equals mx plus b, which is slope intercept. And actually how you do this problem is this. It's kind of interesting. So you know that this was the point -2, 0, and this was the point 4, 2. So you have to pick one of them. I always like to pick the one that has a 0 if possible. So I'm going to pick this one, and I'm going to call that x1. I'm going to call that y1. So that means I have y minus 0 equals the slope, and I'm going to use the 3 because it'll make it easier, x minus 2. And then if I distribute this over, y minus 0 is just y, and I get 3x minus 6. Did I do that right? Oh, that should have been a +2. Sorry about that. Yeah, let's scratch that. We're not going to even worry about it. Okay, what I'd like you to work on for the rest of the period is take a look at page 49 in the yellow, and you can go ahead and do just problems 1 through 4. Okay? Have a nice day. Bye-bye. Bye-bye.